All right, we are going to talk about congruent polygons and how to show polygons are congruent. Mostly this will focus on triangles, so I have two triangles at the top. Pause this at any time if you need to write something down. I kind of cheated a little bit and wrote some of these things down ahead of time. So just in general, congruent polygons are congruent shapes. Polygons are going to be any figure that's sides are made up of line segments. That's close. So I've got two triangles as an example here. But to be congruent, all the corresponding sides and also all the corresponding angles have to be congruent. You either can use information given to you in the diagram or maybe the diagram itself to help make those conclusions. But especially for a triangle here, which is what I've got going on, it would have to be all three sets of sides and all three sets of angles. I marked this for this diagram here just to kind of show you guys. So little single hash mark AB, little single hash mark ED, those two segments are equal. Double hash mark on BC, double hash mark on EF, so those are congruent. And then I got 1, 2, 3, a little bigger with my marker there. Those sides AC and DF, those are congruent. So that, if I was doing a proof, since it's marked in the diagram, I would just say that was given. Now for the angles, what you're looking for is a curve in between the two sides of the angle. So here's angle A, single curve, angle D, single curve. So those two angles would have the same measure. Double curve on B, double curve on E, those two angles would have the same measure. Triple curve on C, triple curve on F, so those two angles are congruent. So all three sets of sides, all three sets of angles are congruent. Now, if you can show that all the corresponding parts, sides and angles are congruent, you can make what we call a congruent statement. And that is just going to match up the corresponding parts in a statement that has a congruent symbol between the two. There's different ways you could do this, so I'm just going to give you one example. Let's say I called this triangle, the first one I have here, ABC. So I'm going to say triangle ABC. And then I'm going to say is congruent to, with the congruent symbol, triangle. Now, here's the tricky part. You've got to match up the corresponding parts. So A is going to go with D in the other triangle. B is going to go with E in the other triangle. And C is going to go with F. So that would be how I'd have to write it. I'm matching up the corresponding parts when I write it in that format. So here's a congruent statement for these two triangles. Now, what I have in example 1, I am given a congruent statement. It says triangle CAT is congruent to triangle JSD. List all the corresponding and congruent sides. Also corresponding congruent angles. Now, not marked in the picture, so I'm going to have us practice doing that. So if you look at the congruent statement, CA, that's the first two letters. The first two letters in the second triangle, JS, means that those two sides should correspond to each other. So I'm going to say AC congruent to SJ, or JS. When you're labeling a line segment, you can flip the letters over and describe the same segment. Let's see. AT, that would be the last two letters. I'm going to put a double mark on that because I don't know if it's the same length as the other that I've already marked. And then SD would be in the same spot. So I'm going to say AT and SD. Those are congruent. And then I got one more set, CT. So I'm going to go 1, 2, 3. That's the first letter and the last letter. So 1, 2, 3, JD, the first letter and the last letter. So we'll say CT is congruent to DJ or JD, either one. Okay, now for angles, this might be a little bit faster, especially since they're separated from each other. So angle A is the middle letter, S is the middle letter here, so angle A and angle S are going to be congruent to each other. I have, let's see, here's D, that's the last letter, here's T, that's the last letter, and I'm going to put a double mark there. So angle D is congruent to angle T. And I'm going to use angle C, 1, 2, 3. That is the first letter. Angle J is the first letter in that other triangle. So angle C congruent to angle J. And there I've listed all three sets of sides and all three sets of angles, which is just a display of what they're telling me in that congruent statement. And all I've got down here, I just scooted up a little bit. These three questions don't give me a picture, they just give me a congruent statement. So I'm going to use that congruent statement to complete each of the congruences below. So QX would be the first two letters in this triangle, so that segment should match up with the first two letters in the triangle it's congruent to. That would be NY. Angle Y is the middle letter in this second triangle, so the congruent angle would be angle X, which is the middle letter in that first triangle. This one says triangle BAT is congruent to triangle FOR. So TA, this would be the last letter and the middle letter. So I'm going to do the same thing over here, last letter, middle letter, so it would be RO. And angle R, that's the last letter here, so it would be angle T, which is the last letter in that first list. Okay, this is four different letters, BAND and LUCK. Those would represent a quadrilateral. So if I've got three letters, I've got a triangle. If I've got four, it's got to be a four-sided figure, but everything else works the same. So angle U, that's the second letter here. So I just need to grab the second letter from the BAND. So it's going to be angle A. DB, that's the last letter and the first letter. So if I want to do this congruent segment, it's the last letter and the first letter. So this would be KL. And this is actually another way to write this same congruent statement. So this goes NDBA. So I'm going to do that same thing here. Should be CK. LU, and that's just another way to write the congruent statement. All right, now we're going to talk about a theorem here really quick, and this is about two triangles and if they have two sets of angles congruent. Now these are not necessarily congruent triangles, which you will notice in my picture. One triangle is smaller than the other, so this is not necessarily for congruent triangles. We're just going to be talking about angles here in this theorem. This is called the third angles theorem, and what it's going to say to you, if you've got two angles in one triangle, so I'm going to use this little picture here, so angles A and B are congruent to two angles in another triangle, so D and E there. What's going to happen from that is that's going to force that third set of angles to be congruent. So if I know two angles congruent and I've got two sets of congruent angles, that's going to make angle C and angle F, which I know this is not in the picture, but I'm going to go 1, 2, 3. Those are going to have to be congruent to each other. And if we have a theorem, remember, you have to prove it. So that's what we're going to do right underneath here. I just copied the exact same diagram. So I'm going to start out with the information that's marked in the picture. Our goal is going to be to prove that angle C and angle F have to be congruent. So we'll do that real quick here. The given information in the problem has angle A and angle D marked congruent, also has angle B and angle E marked congruent. I just put both of those together. That's given to me by the markings in the diagram. Now, these two are separate statements, but they have the exact same justification, so I'm just going to put them together. This says angle A plus angle B plus angle C has to add up to 180. This says in the other triangle, angle D, angle E, and angle F have to add up to 180. That is just the triangle angle sum theorem, and that's just that we know the inside three angles of a triangle always add up to 180. So that's all I'm using there. And if you'll notice, they're both equal to 180. So what you're doing from step 2 to step 3, they're both equal to 180. So they're both equal to each other. So A, B, C added together is 180, D, E, F together is 180. So I know A, B, C and D, E, F, those have to be equal. I would take two different justifications here. You can either say substitution, or you can use the transitive property. Now, this next step should say, I should have a fourth step here, and should say ABC, all those angles added together, is equal to A plus B plus F. Now, what I'm doing right there in that step, A and D, if you look up here, are congruent to each other. So I'm just replacing angle D with angle A is what I'm doing. And then E changes to B. Well, I got that from up here at the top and also from the diagram where we said angle B and angle E were congruent. So I'm just substituting, instead of writing angle E, I'm writing angle B. Everything else remains the same. So that's just me using some substitution. And the last step, what we're trying to prove is that C and F have to be equal to each other. So all you need to do that, and I know this is a little weird, but both sides of this equation have angles A plus B. So if I subtract angle A, subtract angle B, if I do my subtraction property of equality, I have to do the same thing to both sides. That cancels those out and leaves you with C on the left and F on the right. So all I'm doing there, subtraction property of equality, and that's the proof to show why that third set of angles has to be congruent. All right, now we are going to see if we can say that these triangles in this diagram are congruent, and then if we can, we'll use our information to write a congruent statement. Okay, so what I'm going to do on each one of these, real quick, I'm just going to color one of the triangles yellow, and I'll leave the other one white. So I'm going to do that on a couple of these problems here. I know you can't see me doing this right now, but I'm just going to do this to help kind of define what triangles we're looking at in the picture. So for my first picture, ABC is a triangle, EDC is the other triangle. So let's see, we got to get all 6 sets of sides and all 6 sets of angles being corresponding and congruent. So I have one set right here, ABED, and it doesn't look like this necessarily, but they tell you B to C is 4 and C to D is 4. So since those are both 4, I'm just going to put a double mark on that. So that's another set of sides. And C to E and A to C, I'm going to put a triple mark on that because those both say 6. So this side congruent, BC and CD congruent, AC and CE congruent. So I have all 3 sets of sides. Okay, now I do have 2 sets of angles marked. So angle A, angle E, so that's one set of corresponding angles. I have angle D and angle B, and the one we're missing, I can actually have for 2 arguments. What I'm going to do, I'm going to put just a little number 1 right here and a little number 2 right here just to help me label this angle real quickly because I've got so many lines coming in here. But I'm going to go 1, 2, 3. Those 2 angles are congruent. So I'm going to say angle 1 congruent to angle 2. Now, I would take 2 justifications for that since that wasn't already given to us in the problem. Everything else already was, so I got to defend this. I would take that third angles theorem that we literally just went through and proved because I had 2 sets of corresponding congruent angles. That forces the third set to be congruent. Or, if you guys remember this, I'm just going to highlight a little bit. These 2 angles are formed by 2 lines intersecting that makes an X shape there. That's actually also a set of vertical angles. And if you have vertical angles in a diagram, you can actually use that as a justification for why they're congruent to each other because we know all vertical angles are congruent. Now, I do have at this point all 3 sets of sides and all 3 sets of angles corresponding marked congruent or proved congruent by giving this justification. So let me call that first triangle ABC when I write my congruent statement. So if I do that, I'm going A, B, C. I have to make sure when I write the rest of the congruent statement, it goes the same. So I have A is going to go with E. Those 2 both have a single curve, so this has to be E. B, double curve, has to go with D. And C actually would correspond to itself here. So it's going to say ABC is congruent to triangle EDC. Okay, now this picture here. We do have a couple things marked and then we have some given information. So I have one set of sides here and I'm going to get another set of sides just right now from the diagram. I'm going to put a double mark here and XZ. If you guys see there, that segment XZ, let me draw on it with a color here. that side actually is in both of the triangles. It's in the yellow triangle and it's in the white triangle. And XZ, since it's the same segment in both, I'm going to make a statement for my segment or my side pair here that they're congruent to each other because they're in both. The defense for that is called the reflexive property. So that's another set of sides. I know it's really just one side, but it's in both triangles. Now, I don't have any other sides marked. I do have one set of angles, angle W and angle Y, so we have one set of angles. So I need two more sets of angles and one more set of sides to be able to say this is a situation where we have congruent triangles. So then I got to look at what I have up at the top in the given information. Okay, so XZ is the perpendicular bisector of YW. Okay. What can I have from a perpendicular bisector? So, two things. The perpendicular part is going to give you congruent 90-degree angles. In this particular diagram, if XZ, that's this line, and YW, XZ is the perpendicular bisector, that's going to force the angles where I have the 3 and the 4 to be congruent. So here I could say angle 3 congruent to angle 4. They're both equal to 90 because of that perpendicular. My justification be definition perpendicular bisector. What I can also have from that perpendicular bisector, the bisector part, if you have a bisector cuts something into two equal pieces. So if I'm bisecting a segment, this is going to give you two congruent segments or two congruent sides. In this particular picture, XZ here is cutting this line I have in purple into, or it's a bisector here, so it's going to cut it into two equal pieces. So where Z is at, on either side of that, those two segments have to be equal. So for this picture, YZ is going to be congruent to WZ. And my defense for that would be definition of the perpendicular bisector again. The bisector part is what gives me the two segments. The perpendicular part actually gives me the two 90-degree angles. Okay, now I have all three sets of sides corresponding and congruent marked. I only have two sets of angles though. So let's go back up to the given information. This says XZ bisects angle YXW. So let me just highlight this angle here. So this whole angle is not in either triangle. It's literally the outside of a bigger triangle in that diagram there. Now, XZ, this line again, if you bisect an angle, so this bisects an angle, it's going to give you two congruent angles. In that diagram, this line is running into the vertex of this angle, which is X. So I get two equal angles, one on either side of that, which is going to be in this diagram, I'm going to put a double curve, angle 1 and angle 2. So I'm going to say angle 1 is congruent to angle 2. My defense of that would be, because I know I have an angle bisector. Sorry, I should have put definition of angle bisector there. Now, I have all three sets of angles marked, corresponding congruent, all three sets of sides, so I can write a congruent statement. The yellow and the white triangle are congruent to each other there. I would say triangle XZW, congruent, so I went XZ this way, W, so I have to repeat that. XZY is going to be how I would have to write the other part of that, and then I'm done. I showed those were congruent. All right, I have one more, and then we'll do one at the bottom that's just a little different. So here's what I have. Anything I can mark in the picture. So I already have one set of sides, left side, right side, top and bottom. Those are already marked congruent, and I am just going to say, hey, 1, 2, 3, AC, that segment is in the white triangle and the yellow triangle. So I didn't have this marked, so I'm just going to defend this real quick. AC is congruent to itself. That would be your reflexive property. Then I have all three sets of sides. Okay, for angles, I have marked angle B and angle D, so we're good there. Now, I don't have anything else marked. I do have some given information. Okay, if you have parallel lines, which I have two different sets here, parallel lines are going to give you two congruent angles. So if you have parallel lines given to you in the directions, somewhere in your diagram, you're going to have two congruent angles. What you are looking for is either alternate interior angles that you could develop, because those are going to be congruent, or, which you will not see in this particular picture, or we're going to look for corresponding angles. If my parallel lines and a transversal could create either of those types, we can have congruent angles. So let me show you how this works. Specifically, it says AB, that's the left side, and CD are parallel. Okay, this can be tricky. So I'm going to use AC as a transversal. And maybe let me turn my picture real quick, because sometimes people can see this better when the parallel lines are on the top and the bottom. So to form any kind of angle pair, I need two parallel lines and a transversal, which I'm going to use this here. If you guys look at the diagram, angle 2 here and angle 4 here, those are formed parallel line transversal, parallel line transversal. Those are a set of alternate interior angles. So I'll turn this back around here. Here's what I'm going to write. Because AB is parallel to CD, what I can have from that is that angle 4 is congruent to angle 2, and my defense of that would be alternate interior angles. Okay, from that point, I could say, if I wanted to, just from that information, angle 1 has to be congruent to angle 3, and my defense would be that third angles theorem we talked about on the front, because I've got two sets, one set here, and that forces that third set to be congruent. Or, what I'm going to write here, just to show you this as an option as well, because BC and AD are parallel, I'm going to use the same transversal here. Angle 3, 1, 2, 3, and angle 1, 1, 2, 3, using these two parallel lines and this transversal, I'm going to say angle 1 congruent to angle 3. If I use the parallel lines to say that, that defense would be alternate interior angles. So we do have enough here. Now, this particular picture, I would maybe recommend, if you can, I'm just going to redraw the two triangles, but just so they don't touch each other. And you wouldn't have to completely redraw the picture or anything like that. I'm just kind of drawing a sketch. Let me go here and I'm just going to mark, this side has a single mark, double, triple, this is a triple, this is a double, this is a single, just to kind of show you how the congruent statement can kind of be tricky. So this is ABC, and this is A, this is D, this is C. So let's say I said triangle ABC. To match up the corresponding parts here is kind of tricky because it's a little bit flipped almost. So when I wrote that, I went A to B, that was a single mark, then I went to a double mark, and then I went to a triple mark. So I went this, this, this. So I have to repeat that process. So I have to go across the single. So it has to be C to D, then a double, then a triple. So to complete my congruent statement correctly, I have to call the other triangles CDA. Now, I have one last example. This is not a situation where we have a proof or anything. This tells us these two triangles are congruent to each other, and you absolutely do not have to do this, but I'm just going to color one of them yellow really quick. So the yellow triangle here is congruent to the white triangle here. All I'm going to do is see if I have anything that's matching that I could transfer from one to the other. So if you guys are looking at this diagram, angle E is 81. E and C are in the same spot in this congruent statement, so that's going to correspond to C. So I actually, because these are congruent, I know that has to be 81. Okay, now I could just use vertical angles right here where the 51 is. We have this X shape that's formed just by two lines intersecting. So anytime I have that, I have vertical angles. So if this is 51, this will automatically be 51 as well. Ultimately, I'm trying to find X in this problem. And hopefully you guys remember the inside angles of any triangle add up to 180. So I have two angles that I know. Subtract those out real quick and subtract 81, 51. The leftover has to be 48. So actually in both of these triangles, angle D would be 48 and angle A would be 48 in terms of the measure of the degree. The actual question says find the value of X. So they have this expression X plus 5. So I'm just going to say X plus 5 is in the position where it has to be equal to a 48-degree angle. So all I got to do there real quick, I'm going to subtract 5. So my answer to the question there would be that X equals 43, but what I'm doing is using these corresponding angles, and I'm kind of transferring them from one triangle to the other, knowing the triangles are congruent to be able to answer the question there.